this lecture we are going to discuss other ternary 4-phase equilibria. So, as I told you in the beginning that there are 3 ternary 4-phase equilibria possible. The first one was the ternary eutectic. What is that? The first one we discussed extensively is the ternary eutectic, is known as type 1. That is nothing but liquid going to alpha plus beta plus gamma. This is the ternary eutectic. The type 2 is liquid plus alpha going to beta plus gamma. This is known as ternary quasi-peritectic reaction. And type 3 is ternary peritectic reaction, like liquid plus alpha plus beta going to gamma. So, this is known as quasi-peritectic because it can be either peritectic or eutectic type. Liquid plus alpha going to beta or liquid plus alpha, liquid going to beta plus gamma, both are possible depending on whichever is getting activated, but this is a truly peritectic reaction. So, as you know, unlike this type 1, these other 2 types actually a little bit different. Okay, let me just explain one by one. The first one, second one rather, type 2 is shown in this picture here. Okay. What actually happens is that there is a 4-phase equilibrium reaction which is shown at the center, you see, liquid, beta, gamma and alpha, but this is preceded by 2 3-phase equilibria. One is alpha, beta, alpha, liquid, gamma, other one is alpha, beta, liquid. So, these 2 3-phase equilibria can either be eutectic or peritectic type, or both of them can be eutectic or both of them can be peritectic. Now, so that means what? We form these 2 3-phase equilibria among alpha, beta, liquid and gamma descends down to the 4-phase plane. 4-phase plane means what? This plane which is shown as center, and then the 4-phase equilibrium reaction happens, liquid plus beta alpha going to beta plus gamma, correct, it happens. Finally, when it exits from the 4-phase plane, 2 3-phase equilibria forms. One is alpha, beta, gamma, other one is beta, gamma, liquid. That means that still some liquid is left over which can further away undergo ternary eutectic or whatever, any other reaction possible. This is the category number 1. In category 2, which is also known as the type 2, this is very interesting. This is what we will discuss more in details today in the lecture. Type 3 actually, type 3 is the peritectic reaction, and now the ternary 4-phase equilibria will be like this for this type 3. This is like this, it is equilibria between liquid and alpha and beta and gamma, but you know before this happens, this will be preceded by a 3-phase equilibria between liquid, beta and alpha. That is obvious, because the reaction is that liquid plus alpha plus beta going to gamma. Liquid has to react with alpha plus beta, then leading to formation of gamma, and this happens at the 4-phase equilibrium plane, invariant plane. So, before that we must have alpha and beta. If we do not have alpha and beta, how can I have reaction on the 4-phase plane, invariant plane? That is not possible. So, that is why this is always preceded by formation of alpha and beta in the liquid. So, a beta and alpha and beta forms directly from the liquid, then when the temperature is coming down to the 4-phase equilibrium temperature or the reaction temperature, these 3 reacts and forms gamma. Now, this is decreasing temperature obviously. Now, how the exit happens? Exit will be consisting of 3 3 phase equilibrium. First one is alpha beta gamma, second one is alpha gamma liquid, and third one is gamma beta liquid. So, let me tell you that this formation of alpha and beta from the liquid can be directly crystallization of alpha and beta from the liquid or eutectic reaction or so direct crystallization of both alpha and beta, direct crystallization of one of those, not both obviously. Then eutectic reaction will lead to formation of liquid going from alpha plus beta, or peritectic reaction can also lead to formation of. What I mean to say is that first one of these two solids will crystallize like a dendritic form from the liquid, then remaining liquid, the liquid will then react peritectically and lead to formation of beta, or eutectically lead to formation of alpha plus beta. So, basically your task is to form the alpha and beta above the ternary force phase equilibrium plane, right, this invariant plane. So, this can be done by eutectic or peritectic reactions. Now, and once then this reaction will happen, the type 3 phase equilibrium reaction will happen, lead to formation of gamma, and in the exit plane you have 3 phase equilibrium involving liquid, alpha gamma liquid, gamma beta liquid. Okay. This can be either peritectic, mostly peritectic type, okay, peritectic type. What does it mean actually? That means is that below this 4 phase equilibrium invariant plane you can have 2 peritectic reactions or 1 peritectic or eutectic reaction possible. That is what is thing. So, that means if I cool down this liquid directly from the high temperature, first thing will happen either crystallization of alpha or beta from the liquid, then an eutectic or a peritectic reaction which will lead to formation of 2 phases alpha and beta from the liquid, and after that it will descend, this 3 phase equilibrium thing will descend to 4 phase equilibrium invariant plane, which will have this reaction liquid plus alpha plus gamma leading to formation liquid plus alpha plus beta, liquid plus alpha beta leading to formation of gamma, and once it exit from this 4 phase monovariant plane you can have 3 phase equilibria. One is alpha beta gamma, which is understandable, other two are involving liquid, they can be either peritectic or peritectic plus eutectic type. So, this is what will happen, this is a scheme of reactions which is possible. Now, once you know that, once you know this kind of stuff, then you know what do you think about the reactions, right, or what do you think about the diagrams. Okay, let us now see the simplest one which is shown here. Suppose I have a ternary space model which will show the type 3 reaction in which 2 binaries form peritectic, 1 binary form eutectic. You can see AB binary forms a peritectic, AC binary forms a peritectic, but BC binary form eutectic, correct, and this will lead to a formation of type 3 or type 3 actually ternary force phase equilibrium, and it is shown here like that. Okay. These are the zones of primary alpha beta gamma, and this is the this is the eutectic reaction. Okay. Let me change the color, this is the eutectic reaction, and these two are the peritectic reactions, one here, one there. And then at the center what will happen if I extend these points, you get a, this is the peritectic point P2, this is the peritectic point P1. So, if you connect it, you get a peritectic point here, correct. You see here P, capital P. This capital P is corresponding to liquid plus alpha plus beta going to gamma. So, therefore, if I project this whole things, it looks very complex although to you, but that is how things are actually discussed. So, as you see here, because of you have two peritectic reactions and one eutectic. So, if you extend them, this is the extension of the peritectic, this is the extension of another peritectic, and this is the extension of the eutectic. All of them will meet on the 4-phase plane, which is nothing but a given by the point P, and at that plane this these reaction happen liquid plus beta plus alpha going to gamma. Now, we can project it onto the triangle. How we can project on triangle? You can see here this is the alpha phase field, beta phase field, gamma phase field. Then you have a point P here, which is corresponding to ternary peritectic reaction. Point C actually corresponds to is corresponding to this point, which is nothing but intersection between the peritectic reaction between AB and BC actually. C3 extended like this and C2 extended like that, then you get the point C. That is what you get. C3 and C2 are extended, you get the point C, right. And then you have a point A and B are already marked, how point A is coming from these two ends and point P is coming from these two ends. Okay. And P is sitting inside that ternary inside this HGFGH triangle, it is shown here also, correct. So, below the P point P you will have three phase equilibrium reaction. One is nothing but alpha plus beta plus gamma, that is not important. Other two can be of peritectic type, liquid alpha and beta, liquid alpha and gamma, and liquid beta and gamma. Okay. So, this is one such equilibrium things possible. You can also have the last thing I draw is another kind of equilibrium. Let us see whether I can do it. Is that you can also have this ternary phase 4-phase equilibrium of type 3 when you have two eutectics and one peritectic on the binary. So, how it will look like? Let us see. So, let me first draw the binaries. So, as eutectics between A and C, which I have been doing always, A and C. And this is the eutectic, and then another eutectic is between C and B. This is also very easy to draw. They are sitting on this frontal surface, and we are drawing in such a way always B has highest melting temperature, so that you have a consistency in understanding it. So, right, but a third one, that is between A B, forms an peritectic. Okay, I think I have done a mistake here. Yeah, no, it is correct. So, I have got two eutectics, E1 and E2. So, and this is the peritectic, small p. So, therefore, this is TA, TC and TB. TC I am not drawing it. So, now we can extend this these three things. One is the eutectic, other one is this eutectic, and this peritectic. This will form this reaction, right. So, that is how it will look like. Now, one can actually join these points and then get a better idea. So, this is what is this Ternary space model will look like. You have to draw yourself to understand it clearly, otherwise you will not be able to get a feeling of how things looks like. Once you draw it properly, things will be clear to you. So, this is another such. So, therefore, this small p is always used, or small is used to denote the binaries, binary peritectic or eutectic reactions. Capital E or capital P is used for ternary peritectic or ternary eutectic reaction, right. So, this is sitting on that, and therefore, this is actually for sitting on a 4 space plane. One can actually draw even the triangles like that. This is point 1, this is point 2, and then these two actually point 3. So, if I draw it properly, this will look like this, and P is sitting inside that. So, right, that is all. The P is sitting inside this triangle. This is the 4 phase plane. So, therefore, if I draw that properly, it will be like this. Now, what are these? This is P, alpha, beta, gamma, right. That is how I have drawn. So, P is corresponding to liquid, this will be liquid composition. So, that is the way one can draw. There are other things also possible. If I find time, I will show you in the next class, but in the next class predominantly I will discuss type 2 type of eutectic systems, and type 2 is little bit it is not an easy things to perceive 3 dimensionally. This type 3 is still easy thing to perceive, because it is a peritectic. Type 1 is basically ternary eutectic, type 3 is ternary peritectic, but type 2 is a mixture of peritectic and eutectic. That is why we will do at the final thing. So, that is for the next class, and then I am going to discuss with you at the last is this few examples of the ternary phase diagrams. That will be finishing the course. Okay, thank you.